4.4, we're going to talk about trig functions of any angle. So far we've been talking, when we're talking about our angles and our trig functions, we've talked about the unit circle, which simplifies finding our trig functions, because all we have to do is look at the x-coordinate or the y-coordinate to find our cosine and our sine. Or we're talking about sides of a right triangle and we're using SOHCAHTOA. Today we want to kind of blend those ideas together a little bit. So we're going to draw a coordinate system, and we're going to put a point just out here in space. So this is our point x, y. And we're going to draw our angle. So here's the terminal side of our angle. We're thinking about rotating from the positive x-axis, so there's our theta. And I'm going to project this down to make a nice little right triangle. And so this distance, this side of the triangle is x, and that side of the triangle is y. And we can use a Pythagorean theorem to find the length of a hypotenuse. This would be the square root of x squared plus y squared. And we're going to call that, we're going to think about this, if we're rotating on this angle, this rotating is kind of rotated in a part of a circle, so we're going to call that r. And I'm going to just move this down so I can do it. And then we can use these points to talk about the angle to this point. So we're thinking of connecting that point to the origin. We can angle to the point. So using that right triangle, we get our trig ratios. Sine theta is y over r. And cosine theta is x over r. Tangent theta would be y over x. And then we can do our cofunctions. Cotangent theta is a reciprocal, x over y. And then we'll do our secant theta, reciprocal of cosine, r over x. And our cosecant, reciprocal of sine theta, which is r over y. So we're talking about a point in space, and we talk about the angle. We connect that point to the origin, and we talk about the angle at that, sitting at that point, defining an angle for us. And this is all of our trig functions based on the coordinates of the point. So we can find all of these just from the x and the y coordinate of the point. So you don't have to be thinking about a right triangle with, talking about the balloon or the elevation of the sun. We're just talking about a point in space. Now for all of these, we're saying, for these where we're dividing by x or y, we're not dividing by 0. We're dividing by 0 our trig functions undefined. So this is how we define our trig functions of any angle. We just turn the coordinate relate the coordinate in space to an angle. So anytime you see the sine of theta equals something, that always tells you about the sides of a right triangle. So when you see the sine of theta equals square root of 2 over 2, you can think of that in terms of a right triangle. If you see the sine of theta equals 1/5, that's telling you two sides of a right triangle. We can always find the third side, and then we can work from there. So let's look at a couple of examples of how we might use this idea. So we're going to say, the way you might see it in a question in your book, they might ask it this way. Let 4, -3 be on the terminal side of theta. And remember, terminal side just means the hypotenuse. This is where the edge of our angle, if you want to think of it that way. On the terminal side of theta. find the exact value of sine theta, cosine theta, and tangent theta. So what I always do with these kinds of problems is I draw a little picture. So here's my coordinate system. It doesn't have to be a fancy picture. So our point is over 4 and down 3. And here's my little triangle. This side is 4. This side is negative 3. Now the angle that we're talking about is that angle all the way around there. But we can, and we'll talk about this in just a second, we can just think about the triangle in terms of this little angle inside. So we have one side of the triangle, the other side of the triangle. So how long is the hypotenuse going to be for this triangle? One side's 4 and then the other side is 3? 5. It's a 3, 4, 5 triangle. If we weren't sure about that, we can always use the Pythagorean theorem to find the hypotenuse of the triangle. Square root of x squared plus y squared. So the hypotenuse is 5. Now we're set. So sine theta. Sine theta is y over r, negative 3 over 5. Cosine theta, x over r, 4 over 5. And tangent theta, y over x, negative 3 over 4. So these ratios tell us about the sides of this little right triangle, and the coordinates tell us about the sides of a right triangle. So we're relating these ratios to the sides, always relating these ratios to the sides of a right triangle. So in the problem that we talked about where we had the tangent of beta and we had to find the cosine of beta, the way we could have set that one up is if we knew that, let's say if we knew, and I'm not going to go all the way through, let's say we know the tangent of theta equals 5. Well, we could say that is 5 over 1, and then that would tell us about two sides of a right triangle. We could find the third side of the right triangle. So for this one, we would say y equals 5 and x equals 1. How long would the hypotenuse of this triangle be? Square root of 26. Isn't that what we got in our problem? And it had end up with the square root of 26. So r equals square root of 26. And we end up in the same place that we were before. And that identity that we used, the tangent squared theta plus 1 equals secant squared theta, is this, the Pythagorean theorem. So they're really the same thing. So we could have done the problem that way and gotten to the same place. So I'm not going to go all the way through, but we can always think about it that way. We good there? So these ratios always tell us about the sides of a right triangle. Draw your little picture. The picture helps you get the quadrant right, so you get the pluses and the minuses right on all of them. And notice I put a negative 3 there, even though the length isn't negative 3. I put negative 3 because we were going down into the fourth quadrant. Okay. Let's talk about the signs, SIG and S, of our trig functions. So here are my quadrants, here are my axes. So we're dividing our plane up into quadrants. And we want to know in which quadrant our various trig functions are positive and negative. So here's our quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So in the first quadrant, my x-coordinates are positive, my y-coordinates are positive. So what trig functions are going to be positive and what trig functions are going to be negative? All are going to be positive. So all positive. In the second quadrant, my y coordinates are positive, my x coordinates negative. So what would be positive in the second quadrant? What's related to the y coordinate? Sine and cosecant. Sine and cosecant are positive. All the rest are negative. And why don't I'm going to erase this, and I'm just going to write sine theta and cosecant. So those two are positive. All the rest of the trig functions are negative. All right, and I'm going to underline these first letters here. Third quadrant. So both x and y are negative. So what's going to be positive in the third quadrant? All negative? Tangent's going to be positive because we're dividing a negative by a negative. So tangent. And what else? What other functions related to tangent? Cotangent are positive. All the rest are negative. And then down here in the fourth quadrant, our x is positive, our y is negative, so what's going to be positive down here? Cosine theta and secant theta. And the acronym that I never learned acronyms. My teachers were always about thinking about how things worked rather than acronyms, but all students take calculus. Is one way to think of it. There are a bunch of them. So questions on our quadrants and our positive and negative. You might want to add that to your radian the snowman if it helps you think about it. So the kind of question that you might see that has to do with your quadrants. The question would say something like cosine theta is 3/5 and tangent theta is less than 0. We want to find sine theta and cotangent theta. So this is telling us about two sides of our right triangle. What is this telling us? This is telling us our quadrant. We know that the cosine is 3/5 and the tangent is less than 0. So if our cosine is positive and our tangent is negative, what quadrant does that have to put us in? 4. So we're in quadrant 4. So now I can draw my little picture. Cosine is 3/5. We're in the fourth quadrant, so we're down here somewhere. Remember that cosine is x over r. So this is 3, and this is 5. So what does this length have to be? And we're going into the fourth quadrant, so I'm going to say it's -4. Even though the side length isn't a negative, that keeps our direction straight. So now we have everything we need. X is 3, y is -4, and r is 5. So sine theta is y over r, -4/5. So this gets our sine SIG in, positive and negative. Make sure we get a negative. And then the cotangent of theta. Cotangent of theta is x over y. So 3 over -4. And we're set. Now they're not always going to give you 3, 4, 5 triangles in your problems. So you'll have to use a Pythagorean theorem. Just use the 3, 4, 5 to make it easy to see the idea here. We can always use the Pythagorean theorem to find our missing side. Questions there? We're not adding anything really new and crazy to what we've been doing so far. All right. I want to talk about Reference angles, not something that, I don't want to say it's not important. They are not, I guess, not totally necessary, but they can help, they can make your problems a little easier if you think in terms of reference angles. And whenever I draw a picture, when we're talking about the unit circle, and I draw a picture like this, okay, here's my triangle, I'm thinking of I'm thinking in terms of reference angles when I'm thinking of how long the sides of these triangles are. So our reference angles. Let me draw another set of axes, and we will label our. We'll show what we're talking about with a reference angle. So when our reference angle is an acute angle. From the x-axis. So if I draw reference angles on here, I'm going to draw some angles. So this angle would be the reference angle. This angle is the reference angle. So this little one in here. Over here, this angle from the x-axis is a reference angle. And here is our reference angle. The benefit of using a reference angle is that the trig functions of our reference angle are the same as the trig function of our angles from the positive x-axis, except for maybe a positive or negative sign. So the trig function is the same as the original angles. Except for maybe a positive or negative. So this reference angles help us by not having to think about a 150 degree angle. We just think about this 30 degree angle. We don't have to think about a 300 degree angle. We just think about this 60 degree angle. So it can simplify our problem solving that way. And then we just take care of the positive or negative depending on which quadrant we're in. So in this first quadrant, how would the reference angle be related to our original angle? So say we're at a 30 degree angle here. How would the reference angle be related? What is it? We're measuring from the positive x-axis. They're the same. Reference angle is the same. So our reference angle in our first quadrant is just our angle. I'm just going to write how we find our reference angle. So if our angle is theta, our reference angle is theta. In the second quadrant, how would we find this angle from the positive x-axis? Let's say this is a 150 degree angle. What would the reference angle be? 30. How do you find 30? 180 minus. So to find a reference angle, we do 180 minus theta, or we could think of pi minus theta if we're dealing with radians. How about in the third quadrant? So let's say this is a 200 degree angle. What would our reference angle be? So someone said it. So if this was a 200 degree angle, what would our reference angle be? Now remember, it's an acute angle. So if this is a 200 degree angle, what would this little angle be? 20. How do you find 20? 200 minus 180. So we did theta minus 180, or theta minus pi, to find a reference angle. And then finally in the fourth quadrant, if this is a 300 degree angle, what would this little angle be? 60. And how'd you find that? 360 minus. Or 2 pi minus theta. So using reference angles can just simplify your work. You just think about this little angle and then adjust the positive or negative on your sine and your cosine and your tangent, depending on your quadrant. You don't have to do it. You can think about it the other way. Working with reference angles can simplify your work because you don't have to think about a 300-degree angle. You think about a 60-degree angle. So that's the reason that we use reference angles sometimes. And especially when you're talking about applications, if you're doing something in physics and you have this angle here, you work with the small angle and then you just realize that your x-coordinate is negative. So you don't have to work with this big angle. You can work with this little small angle. All right, questions about reference angles? So I just want you to be aware of them, to know that you can use them. They can help you out. They can help you out with solving problems. Okay. I just want to do one more example, and then we're done. Just a slightly different twist on a problem like we did earlier. Okay. And then we will be done for today. Let's say that cosine theta equals negative 1/4. And how do I want to set this one up? Cosine theta is negative 1/4, and sine theta is less than 0. This problem says use trig identities to find sine theta and tangent theta. So we're not going to set it up with a triangle like we did before. We're going to use identities. So first off, what is this sine theta less than 0 telling us? This is telling us our quadrant. If cosine is negative and sine is negative, what quadrant are we in? Third quadrant. So this tells us we're in quadrant 3. So when we find our sine, we know that it has to be negative. We want to use an identity. Well, what nice identity do we have that relates the cosine and the sine? Sine squared theta plus cosine squared theta equals 1. So I'm going to say negative 1/4 squared plus sine squared theta equals 1. And negative 1/4 squared is 1/16. So I have sine squared theta equals 1 minus 1/16. 1 minus 1/16 is 15/16. So sine squared theta is 15/16. And sine theta is square root of 15 over 4. We're in the third quadrant, so I have to put a negative sign. And then, what identity can I use to find the tangent of theta from this? Tangent theta equals sine over cosine. So I get minus square root of 15 over 4 divided by negative 1/4. And what do I get? Square root of 15. So just a slightly different way of doing a problem like we did earlier. Okay, we all good? All right, homework. Every other even here? EOE?